everyone. I will be reporting about setting standard times in work system. Among the commonly used processes for setting standard times are the time study, elemental time data, predetermined time data, and work sampling. The time study dates back to Frederick Winslow Taylor in 19th century. So before proceeding in setting standard times, we should know first what is time study. A time study is a technique for developing a standard time based on actual observations of the operator. Time study sets a standard time based on time observations of one employee taken over a number of cycles. So a cycle includes all the elements of the job. This standard time is applied to all workers doing a job. So I will be presenting the procedures for a time study. In order for us to create a time study and good time study, we should follow these steps. So what are those? Procedure for a time study. Step number 1. Choose the job for the time study. Choose a specific job for you to know or to improve that job easily. As an individual, you set standard for yourself also based on the tasks that you are typical of your workday. For example, I will be doing for today, I will be doing my homeworks for only 20 minutes. So, you're setting your job in a period of time. So, the same thing in your company. You base standard time on the routine that you're doing. Labor-intensive jobs rather than one of a kind. So what are the labor-intensive jobs? These are the examples of the construction, agriculture, coal mining, everything that is done by the laborers. And use this criteria to choose your time job in your step number 1. Step number 2, tell the workers whose job you will be studying. Be sensitive to how the employee will feel as you time performance. Once you're done choosing the job, you already done choosing the job, it is also important to inform the employee in advance that you will be making a time study of the job. So that is the step number 2. Don't be sensitive. Be sensitive in making a time study. Make sure that your employee knows that you're conducting a time study. Let's move on to step number 3. Break the job into easily recognizable units. In a job, there will be more specific job that you're going to do, which is we call it the elements. So step number 3, you must break the job into easily recognizable units. For example, about making a hand-tossed pizza. I have here an example of hand-tossed pizza which are breakdown into elements. So making hand-tossed pizza. Number 1, find the right size ball of dough. Number 2, flatten out the dough. Number 3, spin and toss the dough until it is the size you want. Number 4, put the pizza on the working area. Number 5, add sauce. Number 6, add cheese. Number 7, add additional toppings. Number 8, which is the last, is put the pizza in the oven and bake. You'll be needing these elements as you go on in setting standard time. So let's go back. Since we have already the job, which is step 1, we already let the employee know that we're going to conduct a study. Number 3, we already break down the job into recognizable units, which are the elements. And let's proceed to number 4, which is calculate the number of cycles you must observe. When making a time study, to ensure the results you want, we often express desired accuracy level. For example, we want an accuracy level so that the standard time is within 10% of the mean of the time it takes to do a job. So, let's have here more precisely. In doing a time study, when making a time study, several decisions are made to assure their desired result. If you want a very good results, you should have this. You should have this. Number 1, number of observations to make. How many observations that you're going to make or to observe in the study. Number 2 is the desired level of accuracy. What is the percentage you want of the level of accuracy, and the desired level of confidence for the estimated standard times. Desired accuracy level is typically expressed as percent of the mean observed times. To compute the number of the observations needed, we begin by making a small number of observations so that we can determine the sample mean and the standard deviation. We also need to know the appropriate value of Z to use because it determines our confidence level. So I have here the formula to compute the observation needed in time study. N is greater than or equal the quantity of Z over A times the quantity of S over X close and open parentheses of that quantity raised to 2. So where N is the number of observations of an element that are needed, Z, the number of normal standard deviations needed for the desired confidence. Later, I will be showing the tables or the correct yung katumbas ng percentage sa Z value na gagawin mo. And then the S, the standard deviation of the sample, and A, the desired accuracy of precision, and X bar is the mean of the sample observation. So let's proceed in the table of common Z values. If you want to have a 90% desired confidence, you'll be having a 1.65 Z value, and 95% desired confidence, you'll be having a 1.96, a 95.5, you'll be having a 2.0 Z value, 96 is 2.05, 95 is 2.17, 98 is 2.33, and 99 is 2.55. So don't forget to know this J value because it is already fixed. It cannot be done or anything else. It is already fixed. But it has computation, but we already have this table for use. So, to determine the number of observations, use the formula shown in step 4. You also need a desired level of precision of 5% in this case, in this formula, in this problem that we're going to have, and the sample standard deviation and the mean of the sample observations are already given. So, to determine the number of observations needed, we take some initial observations of the job being studied. In this case, let's observe how long it takes to prepare a large hand-cut pepperoni and cheese pizza. We begin by taking 10 observations of each and 7 elements. The elements, the standard deviation of the observed times for each element, and the mean observed time for each element are already shown in the table. So we need to determine the appropriate sample size of the standard deviation time for any element. So as we break down the elements, taking in step number 3, these are the elements. So we already have the standard deviation, the mean observed time. Sometimes when we're observing, we just use what we call that, in in the cell phone the stop timer in observing, but now we're going to compute how it goes. So, in applying the formula before, which is n is equal to the j over a times the quantity of s over s times parentheses of raised to 2. So, let's try to apply it in work element number 1. So, in work element number 1, the desired, all of our elements, we're going to have a desired level of 95%, which is equals to 1.96 in Z value. So, divided by 0.05, we said earlier that we want a desired accuracy or precision of 5%. So, convert it to decimal point, it is 0.05. And then, the standard deviation of 0.01, and then the mean of 0.12. The quantity is raised to 2. So, we're going to acquire a answer of 11 observations. And as well as in the work element, you're going to apply the formula, and then you're going this, you'll be acquiring this answer. For work element number 2, we have 23 observations. Work element number 3, we have 10 observations. Work element number 4, we have 3 observations. Work element number 5, we have 21 observations. Work element number 6, we have 16 observations. And for the last one, work element 7, we have 25 observations. Work element number 7 has the most observation, which is 25 observations. To ensure the accuracy and confidence needed, we must go on in mean observed time. After calculating the required number of observations for each element, we select the highest number of observations as the appropriate number for our study. So, we already select the highest number, which is 25, and then let's move on, mean observed time. Step number 5. From the calculations completed above, you know that 15 additional cycles must be observed because 25 needed minus 10 that we already had completed. So, it is 15. So, we derive in this revised mean observed time, which is the mean observed time now is 0.15, 0.25, 0.60, 0.15, and 0.30, 0.28, and 0.28. From the revised mean observed time for each work element, we can determine the normal time for the elements. The normal time is different from the observed time because we multiply it by performance rating and factor and frequency of observations. So, before multiplying it, before doing the formula in having the normal time, which is mean observed time times PRF times F, we should know first what is performance rating factor. Performance rating factor is a subjective estimate of a workplace relative to a normal workplace. The observed workplace may be average, above average, below average. As a time analyst, study analyst, you make a judgment about the workplace of the observed worker in terms of how far from the average it is. This is a factor called performance rating factor. If a factor of 1.0 represents an average workplace, any performance rating below 1.0 is below average, and any performance rating above 1.0 is above average. It is vice versa. Rating is an attempt to counterbalance to any unusual patterns noted in the work performance. From any elements which performs below average, the worker may need additional training to improve efficiency. So, from this, we can now know what are the jobs that we need to have focus for us to give, for us managers to give training to have the workers work efficiently in that job. So next one is frequency of occurrence. It is how often the work element must be done in each cycle. One factor to consider the compute in calculating time standard is the frequency of occurrence. We expect most elements to be done every cycle, and if the element is done every cycle, which is no lapses, the frequency of occurrence is equal to 1. And if the element is done every other cycle, the frequency of occurrence is 0.5, which is average half of it is done every cycle. And then, if the element is done every 5 cycles, the frequency of occurrence is equal to 0.2. Dividing 1 by the number of cycles between occurrence is how you get the frequency of occurrence. So, since we already know the P or F and the frequency of occurrence, we can now compute the normal time since we already had the mean observed time. So, what is normal time? The mean observed time multiplied by the performance rating factor by the frequency of occurrence. Normal time reflects how long it may take to produce single large cheese and pepperoni pizza. It does not allow for personal time, fatigue, unavoidable delays during the workday. Therefore, we adjust the normal time with an allowance factor. So, in computing this, the normal time, which is mean observed time times P or F times F, there is no space for fatigue or rest or unavoidable delay. So, in that case, we need to consider also those PFD, which are the personal time, fatigue, avoidable delays. It is the short term of that is PFD. So we should consider also the PFD, the allowance factor, the amount of time that analysts allow to personal time, fatigue, and unavoidable delays. So standard time is equal to normal time times allowance factor. We have two methods to be used. Workers perform several different types of jobs, with some of the jobs more fatiguing than others and jobs having longer unavoidable delays. If that job has a unavoidable delays and more fatiguing than other jobs, we should use the first formula, which is allowance factor sub-job is equal to 1 plus PFD. But if the job is having the same allowance factor and different jobs are unemployed that are similar, if the work of the employee or the job of the employee are only similar and they have the same allowance factor, we can use the AF, allowance factor, time work, is equal to 1 over 1 minus PFD. So, let's try to know and to try it. So, we already have the mean observed time lately, the revised mean observed time. We have performance rating factor, and we have frequency, which we said already, the 1 and the normal time. In order for us, for the normal time, we should times the mean observed time, performance rating factor, and the frequency. For example, in work element, we multiply 0.15 times 0.90 times 1. We're going to acquire the amount of 0.135. So, as well as in every element, you're going to do that. So, once you're done, you'll be acquiring the total number of minutes is 1.9666. Let's look at numerical comparison of the two methods. For setting the allowance factor, if the allowance factor of PFD is 0.19, we compute the allowance based on the job as AF is equal to 1 plus 0.15 equals 1.15 or 115%. When computing the allowance based on the time work, the result is 1 over 1 minus 0.15 is equal to 1.76 or 117.6%. So let's move on to step number 7. Now that we know how to calculate the allowance factor, let's continue with our pizza making example and determine the standard time. The standard time equals the normal time multiplied by the allowance factor. So the formula it shows here the ST is equal to standard time, the NT is normal time, and the AM is the allowance factor. Solving for work element 1 in our example, we have 0.135 is the normal time that we had earlier, and then 1 over 1 minus 0.15 is the times the quantity of normal time is equal to 1 over 1 minus 0.15 is the allowance factor. So we multiply it in 0.135 and we will be having a 0.159 minutes. The standard time for the standard times for each element using a 15% allowance based on work time are shown in table 11.7. So this is the one. The element, we already have the normal times. We already kept that earlier. And then the standard times here. And then we added up. The total of normal time is 1.966. And the standard time is 2.313. The standard time for preparing a large hand toast and cheese and pepperoni pizza is 2.313 minutes. This means that during 8-hour day, our worker should be able to prepare 207. It is 480 minutes per 8-hour shift divided by the standard time of 2.313 minutes. Large hand toast and pepperoni pizza. So your worker should produce a 207 hand toast, cheese, and pepperoni pizza in a 8-hour day work. So before we go on, let's make sure that you understand the SAGI. So let's think of these key points for us to understand more easily. And the first step is identifying the job you will study. This is the first step I had talked earlier. So break the job into small, easily recognizable work elements, which allows you to analyze different elements. Look for ways to improve the existing operations. So identify areas where workers need additional training. To determine the number of observations needed, you must consider the variability of observed times, the desired level, and the desired level of confidence for the estimated standard times. Take some observations as you can determine of the observed time. The degree of accuracy and level of confidence of factors are managerial decisions. After determining the number of observations needed, you must perform any necessary additional observations. Using the observed times, calculate the mean observed time for each work element. And calculate the normal time, multiplying the mean observed time by performance rating factor and the frequency of occurrence each work element. Adjust the normal time by multiplying it with the appropriate allowance factor. So that's all in setting standard time. Setting standard time makes you, as a manager, helps you to know which job you need to have a focus so that you can have training for your workers, for the workers to work efficiently more fast